In this lecture, we are going to see the remaining topics which we have not seen in the class. And this lecture is going to be prepared for third year A and B mechanical engineering students. So the topic is automobile engineering, and the unit we are going to cover in this lecture is steering, brakes, and the suspension system. So what are all the topics we are going to cover in this lecture is given here. So we are going to see first the hydraulic brake system, and followed by pneumatic brake system and anti-lock braking system, and at last electronic braking force distribution, that is called as EBD, which is also called as a traction control. So these are the topics we have left in the classroom session, as we are hurried up in order to meet the model exam scenario. So in this online lecture, we are going to cover this remaining topics. So let me move on to the first topic, hydraulic braking system. So the name itself implies hydraulic braking system is the braking system which implies the pressurized fluid force in order to achieve the effective braking efficiency. So we know braking efficiency, the term defines what's meant by braking efficiency. So it is the amount of braking force applied to the total weight of the body. So this ratio or this fraction is defined as a braking efficiency. So for getting a proper braking and for getting this proper braking effort, so we have to provide some force. We have to provide a braking force in the brake pedal of the vehicle. So such braking effort can be achieved in two means. So one via hydraulic braking system, and next one via pneumatic braking system. So in this case, hydraulic in the sense the pressurized fluid. We are using the medium, the pressurized fluid medium to create such braking effort. So that means only this layout is considered to be the hydraulic braking system. So the image shown here is the typical layout of a hydraulic braking system. And now we are going to see about what are the major components included in this hydraulic braking system. So one master cylinder, one wheel cylinder, and brake fluid. So typically the brake fluid consists of a mixture of glycerin and alcohol, either this mixture or a castor oil. So these are the three major components we are using in this hydraulic braking system. This image represents a typical layout of the hydraulic brake. So in this layout, we can see the brake pedal and the fulcrum pin, or the joint which joins the brake pedal and the master cylinder. This region is called as the master cylinder of the brake system, so hydraulic brake system. So this master cylinder consists of the piston and a master cylinder with a return spring mechanism. So this master cylinder in turn connected to the other four wheel. So this is one wheel, and this is second one, and this is third one, and this is the fourth wheel. So this master cylinder, which in turn connected to the other four wheel via these tubes. So at the end of each tube, so this component is called as the wheel cylinder component. So so in the figure itself, the master cylinder is barely attached to the wheel cylinder, and the wheel cylinder at the both end of the wheel cylinder, here it's the brake shoe attached to the wheel cylinder. So this type of the arrangement is copied or replicated in other three wheels itself. So this is the basic construction of a hydraulic braking system. So now we are going to see how it will work. So once a pressure is given here or a brake pedal is applied here, this joint which exerts a fluid pressure inside this master cylinder. So upon exerting a higher pressure in this master cylinder region, the exerted pressure will leave through these tubes and reach the four wheels via this tubular columns. So at the end of the each tubular column, there will be a wheel cylinders, and the wheel cylinder which in turn press the brake shoe against the rim of the wheel. So for this sorry, in this action there will be a frictional force created in this region. So like here I will show here. So once the wheel cylinder presses the brake shoe, so against the wheel rim, here in this region we can we can experience a frictional force between the brake shoe and the wheel rim. So apparently we will get the braking effort. So due to the friction between these two linear motions, so which means the motion between the wheel and the stationary object brake shoe. So this is how a hydraulic braking system will work effectively. And next, so this system is called as a pneumatic or compressed air brake system. So in the last topic, we have seen the hydraulic system, and here followed by the hydraulic system, we are going to see about the pneumatic. So we know the difference between the hydraulic energy and the pneumatic energy. So in this pneumatic energy, so it is nothing but the highly pressurized air. So in the last case, we had seen about the pressure of the fluid. So pressurized fluid we have taken into account as a source, but here in pneumatic operation, so pressurized air is taken into account as a working medium. So here is the components of a hydraulic brake system. So this layout and the previous one, hydraulic fluid system layout, is typically looking like the same, but accepting some changes in the layout. So in this pneumatic system, we have an air filter, an unloaded valves, an air tank, brake valves, and a brake chamber. So these are the major components involved in the construction of this pneumatic or compressed air braking system. So this is the layout which represents the pneumatic air brake system. So this the placement of components is given in this layout clearly. So first of all, air is coming from the atmosphere which enters into the filter. In this filter, so the contaminants, so microbes and minimal dust particles are filtered through this filter, and it will enter into the compressor. The working of compressor, we know what a compressor would do. So it will give the pressure, or it will increase the pressure of the incoming atmospheric air. So once the pressure air get pressurized, it will enter into this unloaded valve. So this unloaded valve is it's nothing it's working similar to like a pressure relief valve. So once the valve will get excess air pressure, it will enter into the brake valve. So this acts like a modulator, so or like a distributor. So in this region, so the pressurized air will get distributed to the all the connected wheels in the automobile system. So this is how a pressurized air from the atmospheric air enters into the compressor and get pressurized, and then getting into the unloader valve. So from that unloader valve, it will enter into this air tank. This is called reservoir. So from that reservoir, with the help of this brake valve, which means this brake valve only uh, distribute the pressurized air into the wheels. So this is the working and proper layout of a pneumatic compressed air brake system. So this region explains or shows the valve, this brake valve, in a scaled up manner. So in this valve, we can see a lot of components, a lot of parts to be assembled to get this valve. So at first, so this is called as initial inlet valve, and this is called as exhaust valve. So from here, so this region, so this stem is called as the piston. So with a return spring mechanism. So the spring will return, and there is an exhaust port. So once the air from the atmospheric air, that compressed air from the compressor is getting in from this way. So once the air gets in, the inlet valve gets compressed, and then exhaust valve, which in turn press the cylinder to this region. So this is because of the inlet compressed air. So once the air pressure is fully exerted in this region, so the excess air will release through the exhaust port. So from this exhaust port, the pressurized air will get distributed through the other wheels, all the sorry, not the other wheels, all the wheels of this uh, of the vehicle automobile. So this is how this brake valve or the valve mechanism would work. Next, so the next braking system is we are going to see as we all we might have come across this word day by day. It's called as it's nothing but an ABS. So ABS stands for anti-lock braking system. So the name itself implies the anti-lock. So this term implies, so it will prevent the locking of the wheel motion. So which will in turn cause the slippage, and that will end up with an major catastrophic accident. So in order to prevent the wheel slippage or wheel locking, so majorly wheel locking, so the reason vehicles are come up with this ABS equipped automobiles. So what it will do? So what is the difference between the conventional braking system and this anti-lock braking system? So in this anti-lock braking system, actually it's a form of an electronic braking system. So what are the electronic components installed in the system? We will see below. So the ABS is mainly invented to help a driver to control a vehicle under heavy braking conditions. So when an unprecedented hurdle uh, will appear in our pathway, so just assume if you are going in a vehicle with a speed of 60 km per hour, so unprecedentedly when any animal, so animal or any hurdle, so unprecedented hurdle uh, crosses our path, so a driver in turn applies the brake suddenly. So in that case, all the wheels of the automobile will get excess air, the pressure, whether it may be a hydraulic or a pneumatic pressure. So that will leads to the wheel locking. So in order to prevent that locking, this ABS should be installed in all the vehicles. So this ABS installation is a mandatory one in case of the current Bharat Stage 4 norms. So as I said earlier, so the preventing the wheels from locking, we have to install this ABS. Now we are going to see about the components of an ABS. So what are the major components? So first one is wheel speed sensor. The component sensor, which implies there will be an electronic control unit obviously in the ABS system. So as we see in this first point itself, it's a form of an electronic braking system. So in case of electronic braking system, the electronic uh, control unit, which will be comprised obviously of a sensor, valves, and motors and accumulators. So these are the major components. Once again, I will repeat. So wheel speed sensor, electronic control unit, which is also called as ECU, modulator valves, pump, motor, and accumulator. So here, this is the typical layout of or a simple layout of an ABS system. So here we can see the all the major components listed in the previous slide. So this one is the pedal, so braking pedal of an automobile. So here this is the fluid reservoir and a tube which will connect the reservoir and the wheel. So this is the wheel rim. So wheel rim, and this portion is called as is known as the brake pad. So this wheel rim and brake pad, or this disc, this wheel disc and brake pad will get stick together when a pressure is applied here. So but how it will work? So what is the difference between the conventional braking system and the ABS equipped system? So this circuit or this portion is called as the ABS installed or ABS equipped region. So what would generally what would be the process is going on here? So that's the major thing we are going to see here. So once the brake pedal is pressed, so this brake pedal creates a pressure or pushes the brake fluid from the reservoir to the brake pad with the help via this tube. So in case of any emergency situation, so if you want to brake, if you want to stop the vehicle whenever the vehicle is moving more than 60 or 70 kilometers per hour, so if we apply brake in this condition, definitely or obviously the wheel would tend to lock. So in order to prevent this locking, we have to equip this mechanism. So what's going to be the best part here? So it's clearly shown here in the step-by-step manner. So at first stage, the driver pushes the brake pedal, and second, the piston pushes the brake fluid from the reservoir, and third part, the brake fluid squeezes brake pad into the brake disc. So here it will occur. So once the brake pad presses the brake fluid squeezes the brake pad into the brake disc, here there will be a friction. So because there will be a relative motion or a relative contact between this brake pad and this rim. So this is the fourth stage. The sensor here, the EC unit comes into the play. So the sensor detects when the wheel is about to lock. So here is the sensor. The sensor consists of it's like a gear profile. So whenever each tooth of this gear will come into contact with these dots, you can see clearly in this picture. So there will be a difference between air gap with the each tooth of this gear and this air gap. So from that instant, a signal is sensed by the sensor, and it will send to the control unit, and this is the control unit. The signal sensed, the signal sensed by the sensor here, and it will be sent to the EC unit. So via this line. So in this unit, we can see two major components. So this is the pump and this is the accumulator. So once, so this is the next step. So control unit activates the accumulator and pump. So this is the control unit, and this control unit will in turn activate the accumulator, and this is the accumulator, and this is the pump. So what will happen here? So the fluid is built off into the accumulator or reservoir. This release brake pad pressure. Once this sensor sensing that wheel is going to lock, so that's the sensor's prime duty. It will send signals to this ECU unit, and this ECU unit activate this pump and accumulates the ongoing fluids, and it will stop the motion of the fluid, and that will reduce the pressure between the brake pad and the rim. So this is how ABS will work. So what would happen further? So within the 15, so here you can see, so this process, once the brake pressure is released, so again the fluid pressure will create a brake in this in this pad, and again there will be a friction will happen between the pad and this rim. So this is the sequence of operation is occur once the brake is applied in an extreme condition. So this process, which means the fluid is pumped back and to reapply the pressure. So the pressure is applied and released, applied and then released within a 15 times, which means for in a per second, in 1 second. So this simultaneous operation, so that is pressurizing the or like creating the friction between the pad and the rim, and then releasing the pressure. So this simultaneous operation would occur 15 times in per second. So we can imagine so how precise this work would be. So this is from this action, we would be saved with the help of this equipped ABS system. So this ABS system, you can clearly understand now what is the difference between the conventional one and the ABS one. In the conventional one, once we applied the pressure, the whole fluid pressure will create a strong contact between the brake pad and the rim, which will definitely create a slipping or locking of the wheel, and it will create a slippage, or it will reduce the traction force between the wheel and the road surface. So that will tend sometimes the vehicle will roll out. So in order to overcome that issue, so we have equipped an ABS which will create the successive operations like pressurizing, creating the braking effort and releasing the effort, again creating the braking effort and then releasing the effort in intervals of 15 times per second. So this is how a wheel would be free from that locking problem. So this is the layout, clear layout and the proper working of the ABS equipped automobiles. So this is the last part of this lecture. So electronic braking force distribution, EBD. So which is also called as traction control. So EBD or EBFD, so electronic brake force distribution or electronic brake force distribution or electronic brake force limitation. So these three term implies the same meaning only. So EBD or EBFD or EBL. So it's an automobile brake technology. So before going into this topic, so I want to emphasize one thing here. So this EBD and the previous seen ABS both working would be looking too similar. So this is also an electronic braking system. So usually a vehicle with ABS equipped obviously will equip with this EBD. So that automatically varies the amount of the force applied to each vehicle. So this is the difference. So this is the major difference. So in the previous case ABS, so that's mainly meant for preventing the vehicle from locking. But here it will automatically varies the amount of force applied to each vehicle. So let us consider a car. So a car will obviously having a four vehicle wheels. So this EBD traction control, this EBD equipped vehicle will sense the wheel of each vehicles each wheel. So if a car is having four wheels, this EBD will sense the speed of the each wheel of the vehicle. So based on road condition, so what is the condition of the road, whether it may be it will be a dry condition or it's a rainy condition. So what is the speed of the vehicle and what is the current load of that vehicle. So these are some parameters it will taken into account while sensing the vehicle speed. So you may be clear the difference between the ABS system and this EBD system. So here is the major components of the EBD. So one is speed sensor and another one is ECU, electronic. Again, it's an electronic control unit equipped uh, braking technology. So wherever you see the electronic or ABS or EBS traction control, so all this technology is embedded with this ECU, so electronic control unit. So this is the heart of uh, this braking technology and modulators. So modulators is nothing but the actuators. Like we have seen actuators in hydraulics and pneumatics theories. So the modulator is nothing but it's like a distributor. So distributing the energy, that may be a hydraulic energy or pneumatic energy. So this is the layout of the traction controlled equipped automobile. It's a clear layout. So we have seen. Oh no, sorry. We can see clearly. So what are the major components indulge in this um, assembly? So we can see wheel sensors. So as we have seen in the ABS. So this is the exact sensor diagram. So this is the same sensor which we have seen in the previous ABS layout. But in that case, we can't see this sensor in the scaled up manner. But here we can see the sensor clearly. So this is the this yellow gear shaped profile is the one I had told earlier in case of ABS. So this gear having teeth. So this is the sensor probe. So in this is the air gap I have told earlier. So once each tooth of this gear will comes near to this probe. So there will be a difference between air gap. So this is the probe and this is the tooth and this is the air gap. So there will be a difference between the probe tip and the tooth. So thus this wheel sensor senses the speed of the vehicle. So actually this toothed gear uh, will be fixed to the rim, will be fixed to the wheel itself, right? So whenever the wheel rotates, this toothed gear profile will also rotate. So which will create pulses. So in term of this air gap. So once the wheel sensor will sense the vehicle speed and it will send the information. It will send the signals from the all the four wheels to this module. So this is the ECU module. So from this module, a single signal will come to this modulator unit, and this is the modulator unit. It's nothing but a distributor unit. So this ECU unit will calculate how much of braking effort should be distributed to the each wheel. So this is the major working of this ECU unit. This ECU unit will calculate how much energy will be distributed to each wheel according to the sensed signal. So it's not like ABS. So ABS will create a continuous braking and releasing mechanism in interval of 15 times per second to all the wheels simultaneously. But here in traction control or EBD control, the signal from the wheel sensor will lead to the ECU unit, and ECU unit will decide how much amount of braking effort should be given to each wheel. Each wheel in a varied manner. So which in the sense, so each and every wheel should get pressure in variation. So that's the major significance of this uh, traction control unit. So why we have to install this traction control unit? So obviously there will be a ABS and that will prevent the wheel locking. So why we have to go for this EBS? So the reason behind this is in case of ABS, we can prevent the vehicle from slipping. But in case of traction control, so this is also bringing the same uh, output as like ABS, but this will reduce the speed. This will vary the speed of each wheel of the vehicle. That will prevent more ahead of the ABS. So this is the that is the major reason for implementing or equipping this traction control along with the ABS. So with this, we will complete the unit 4, and we hope you would understand all these concepts and working mechanisms of each and every braking system, whether that may be electronic or hydraulic, which is conventional type, and the later we had seen about ABS and this traction control, which is equipped in the in current recent vehicles. So you might have understand. I hope you could get more idea about both conventional and recent braking system equipped in the automobile. So if you have any queries, please contact me at any time through my mail. I have given my mail in previous video lecture itself. So you can go through it, and please go through this video and watch carefully. If you have any doubt, please feel free to contact me at any time. Thank you.